Hi, today we're going to be talking about section 2.5, scatter plots and lines of regression. Really we're just going to learn how to make a scatter plot really quick, try to make a prediction line, and then figure out how to use our calculator, specifically the TI-84, to make regression lines. So if we think of a scatter plot's made up of two pieces of data. So maybe you have your height versus your arm length or something like that. Really just two pieces of data that have to do with each other. In real life we have data, it almost never fits in a perfect line. So you can see these two, the data is linear because it forms the shape of a line, but it's not in a perfect line. It doesn't all line up perfectly, and that's very normal. That's how most of life is. It's never going to end up being just a perfect linear relationship. But when it forms a nice line like these, you would call this a strong positive correlation because they're very nicely, they're tight in a line here. If you look here, each of the points are not that far off the line, so that's a very strong positive correlation. It's positive because that slope of our line of best fit there, or the line that was drawn, all the points are really close to that line. Okay, so its correlation is just how tight together are your points. Are they really tight together in a line or not really? And then the positive or negative is just if it's going up or down. If you look at this says this is weak negative correlation. I wouldn't necessarily say that's super weak. I wouldn't say it's strong. It's not as strong or not as tight as this line is, but I wouldn't call it super weak. I'd just say that's kind of medium. So I kind of disagree with this statement saying this is weak negative correlation. But this one, you would have no idea where to draw a line. I don't know if it's going this way or this way. That's no correlation. There's no way you could figure out how to make a good line of best fit based on that data. So that's correlation. We're going to show something called the correlation coefficient that our calculator will calculate for us that'll make it much easier for us to talk about. Is the strong correlation, weak correlation, what kind of correlation does it have, and is it positive or negative depending on its sign. So what I want you to do is I want you to make a scatter plot. This is data that's the year versus a price of a home. So go ahead and make your line of best fit. Just draw an x-axis, that will be the years. So you might want to put that in terms of t instead of x, and then a y-axis in terms of price. So maybe you make it a p instead of a y. But just make your scatter plot based on the data that's provided here. Go. Okay, so the first thing obviously we need to do is draw an x and a y-axis. Okay, we need to go 1, 2, 3, 4, 5. So 5 years that way. So that's year 5, and I'll make this in terms of t instead of x because it's time, and maybe I'll put in years. Okay, for our y values, I'm seeing that's going to be price, so I'm going to do price in dollars. Okay, I need to get up to about 300, so I'll call that 300, so then that would be 2 and that would be 1. So that gives me a place to start with my scatter point, or scatter plot. So let's see, if I go 0, 154 would be about there, 1, 166, 2, 189, 3, 207, 4, 228, and 5, 273, so a little bit higher there. It's not a great scatter plot, but it's not terrible. Okay, then you need to try to draw a line of best fit. So if I was going to draw a line of best fit, when I think about drawing this, a lot of people will say, okay, you need to split the data. Well, if I drew a line like that, I just split the data. Is that a good line of best fit? I think you would agree that's a terrible line of best fit. That doesn't represent the data at all. So it's not just that it has to split the data, it also has to match the slope. Well, the slope of the data, if I look at this, it looks like it's kind of going up like that, so I need my slope to match that same slope. Well, if I just match the same slope, this line here has the same slope of that data, but it doesn't even split any of the data points. So it can't just be one way that you describe how do you draw a line of best fit. It has to be multiple ways. You have to not only split the data, but you also have to match the same slope. So if I try to split the data and match the slope, that was okay. It could have been better. It'd probably be a little bit lower, would be a little bit nicer line of best fit, because most of my data is underneath except for this point here, and then this point and this point is touching. So if I could slide that down just a touch, I probably would. But for me to do that on the iPad is not realistic. I won't draw a very good line of best fit with about 10 tries. So we're just going to leave it like that. Okay, it also says to write the equation for the prediction line. Okay, well, since I said it looked like mine was crossing right at this data point here, I'm just going to make that my y-intercept. We'll just call it 155, just to have a nice round number for me. Okay, and then I just need 2 points that it crosses. So it looks like it goes through that point and that point for me. So I'm going to use those 2 data points, which would be this point here, and then 1, 2, 3 would be this point here. So I'm going to use those 2 to find my slope. So I know it's y2, 207, minus y1, 154.5, over 3 minus 0, which is equal to 17.5. So that's my slope, so I go y. Now, when you're talking about a prediction line, you want to put this little hat above your y. Okay, so y hat is equal to, so that just tells me it's a prediction line or a line of best fit. Okay, y hat equals m is 17.5 x plus b was that we said it crossed at about 155. Okay, really, because we said price and time, you should probably say p hat equals, I'm going to write it back up here actually, p hat equals 17.5 t plus 155. So that's probably how I would draw that one. Now predict the selling price of a home for 8 years. So we go, okay, the price is equal to 17.5 times t. T is 8 years plus 155. So that's equal to, type it in, 295, but we have to times that by 1,000 because it says prices in terms of 1,000, so I'll add that on. So we would say that 295,000 would be a good prediction for a selling price of a new home after these 8 years. How accurate does this look? Well, if we look at our data here, we talked about correlation, and if we look at that, that's pretty strong correlation. Our data points are really close to that. So I'd say this is pretty strong correlation based on the way that was drawn. Okay, this is pretty much the last time we'll do a line of best fit by hand. I want you guys to be able to use your calculator to do. Here's where we're going to give this a shot. I was going to try to play a video for you, but it wasn't working on here, so we're just going to take these screenshots. So I labeled each screen 1 through 10, so just try to follow along. Number one thing you have to do is we have to turn on, in order to get our calculator to calculate what the correlation coefficient is, we need to turn our diagnostic on. So if you see on screen 1, my finger right at the bottom there is right on the 0. Right above that it says catalog. So if you hit the second key, which is the upper left button, that second key, and then 0, it will take you to catalog. If you look at the second screen, we need to turn our diagnostic on. So scroll down until you get to diagnostic on, which there will be a lot, so you'll just need to keep scrolling. It's alphabetical order. You can hit the D button, it'll take you straight to the D's if you want to go a little faster, but you can just scroll all the way down. When you get to diagnostic on, hit enter, and then hit enter again until it says done. Once you've done that, your diagnostic is on, and now our calculator, when we when we use it to calculate our regression line, it will also calculate the correlation coefficient, that R value. Okay, on to screen 3. Now we need to input our data. So if you go to stat, if you look where my finger is, it's right above the stat button there. Hit stat, and then once you're up there, it'll show that screen. And then you just have to hit enter on edit. We want to go stat, edit. Then it will pull up your lists. So if you don't have all of your lists, right, you need to hit stat, then you need to go down to setup editor, hit enter and reset it, hit enter again until it says done, and that will reset so you get all your lists back. So just in case, if you don't have your list show up, like L1, L2, like let's say it says L2, L3, L4, and there's no L1, you'll need to reset your setup editor. So little side note there. But what you want to do is normally we want to enter in new data. So the easiest way to do that, if you see the screenshot number 4 there, shows L1 is being highlighted. So you need to go up to L1 and highlight it, and then you can hit clear, and then the down arrow, and the down arrow will go back down, and it will then clear your whole list. Okay, and you'll want to do the same thing for L2 so that you can have 2 places to enter in the data. So we're going to enter the data into L1 and L2. So go ahead and do that and enter the data from the last problem in. So go back, if you need to hit pause and go back and find that data, you need to enter in all the data. So you can see I have all the data entered in here on the 2 lists. So hit pause now if you need to before going on to the next step. Okay, the next step would be to go to our stat plots and turn them on. So if you look where my finger is again, right at the Y equals button, right above that it says stat plot in blue. Again, to get to the blue you have to hit the second button first, and then that Y equals will take you to the stat plots. Now when I did that on mine, my plot 1 was already on. If yours is not, you need to hit enter, and you need to highlight on and hit enter so that you've turned your plot on. Okay, then moving on, we go on to screenshot number 6. You want to hit the zoom button so you can see where my finger is, hit zoom, and then you want to go down to number 9, and you can either hit 9 for zoom stat, or you can hit enter once it's highlighted on 9. Once you do that, it will take you to screenshot number 7, where it should give you your scatter plot. If some other line appears on there, that means on Y equals that you have another graph that's being graphed, so you might want to go to your Y equals and clear that, and then do zoom stat again, and yours should look pretty close to mine. From there, if we go on to screenshot number 8, we want to hit stat again, and then calculate this time. So when you hit stat this time, so if you look back at screenshot 3, that's where the stat button is. And then instead of staying in that first column, we need to go to the right one to get to calculate. Okay, when you get to calculate, it'll show this list, and the 4th one down says LinReg. That stands for linear regression. That's the type of line we're making. Linear regression, it's in the form AX plus B, which is what your calculator uses instead of MX plus B. So we use MX plus B, your calculator here has AX plus B. So then you'd hit enter. Now, if you have an older calculator than mine, it will just come up and say LinReg, and then you just hit enter again, and then it will calculate it. If you have a newer calculator, you'll get screenshot number 9 like mine, and you'll have to go down and highlight calculate. You can, where it says store regression equation, you can, on that line if you want to, type in, so you'd hit vars, which is variables, then you have to go to function, and then you can put in y1, and then it will actually put that equation into y1 and you could graph the equation. So if you graphed it again at that point, looking back at screenshot number 7, it would actually graph the line of best fit on there. So that's pretty cool if you want to do that. But just keep it simple right now. Go down to hit calculate, then hit enter, and it will take you to the screenshot number 10 that says linear regression. So what you need to get out of this is we need to then pull the equation. We need to say from there on your test what you'll need to write is y hat, signifying it's a line of best fit, is equal to 23.06 x plus b is 144.4. Okay, so that's our equation line, and then if you look at the r value down here, says an r value of 0.97. If your data is in a perfect line, you will get an r value of 1 if it's got a positive slope, or a negative 1 if it has a negative slope. That is a perfect correlation. That is not how life usually works. So hardly ever will you take real data and get a correlation coefficient of 1. But that would be perfect, super strong correlation. Okay, but a 0.97 is very strong correlation. So this is very strong positive correlation. The correlation coefficient is positive. If you were to draw a line of best fit, we talked about that already on the last slide. We thought this was going to be a nice strong correlation. Okay, so I'm going to have you practice one more. So go ahead and try to put this table into your calculator following the last steps that we just did on the last problem. All right, then really bring in your questions if you aren't able to get the same equation that they got for the line of best fit, or at least something very close. So I want you to give this a shot. This is the end of the video. Bring in questions from this because I know that was a lot to do, seeing it as screenshots on a calculator. So bring in lots of questions.